Hello, dear learner. Myself, Shivanjali Tagade from Delonix Society's Baramati College of Pharmacy, Barhanpur, Baramati. In this video, we will discuss on topic fluid energy mill, subtopic from chapter size reduction under the guidance of Mr. C. Krishna Baukar sir. Points we will cover in this video are definition of size reduction, introduction of fluid energy mill, principle, figure, construction, working, applications or uses, advantages and disadvantages. So let's start. Size reduction. Size reduction is the operation carried out for reducing the size of bigger particles into smaller one of desired size and shape with the help of external forces. Size reduction is a process of producing large unit masses, vegetables or chemical substances into small unit masses, coarse particles or fine particles. Introduction of fluid energy mill. Fluid energy mill is also called as jet mill. It is based on a cold stream impact process in which the materials are disintegrated by collision of a particle with a particle, a stationary target, or a wall of the containing chamber. Next, we will see the principle of fluid energy mill. It operates on the principle of impact and attrition. Impact occurs when the material is more or less stationary and is hit by an object moving at high speed, or when the moving particles strikes a stationary surface. In either cases, the material breaks into small pieces. In attrition, pressure is applied on the material as in compression, but the surfaces are moving relative to each other, resulting in shear forces which break the particles. Simply, impact is force of action applied on another object by one object, and attrition is rubbing of the particles. Next, in these equipments, the material to be milled is suspended within a high velocity airstream. Milling takes place because of high velocity collisions between the suspended particles. Means, as we introduce high velocity air stream in the chamber, the particles get collide and the size is reduced. This is figure of fluid energy mill. In this, it is shown that the equipment consists elliptical loop pipe, classifier, an outlet, feed inlet, venturi feeder, fluid nozzles, and compressed air supplying pipe. Construction. It consists of an elliptical pipe which has a height of about 2 meters and diameter ranging from 20 to 200 mm. The mill surface may be made up of soft stainless steel or tough ceramics. Grinding nozzles may be placed tangential to the initial flow path of a powder. Compressed air of pressure 600 kilopascals to 1 megapascals are used. Inert gases are used to minimize or eliminate the oxidation of compounds. Venturi feeder is provided in the path of airflow. An outlet with classifier, cyclone separator or bag filter is fitted to allow the escape of air. Here we see in the diagram hopper for inlet of feed, venturi feeder, compressed air supplying pipe, a cyclone separator for the separation of air and small particles. Next, working of fluid energy mill. First, powder is introduced through the inlet of venturi. The air entering through the grinding nozzle transport the particles in the elliptical or circular tract. In the turbulent stream of air, the suspended particles collide with each other and break. Thus, impact and attrition forces operate in size reduction. The resultant solid particles are carried to outlet and removed by cyclone separators. The coarser particles undergo recirculation in the chamber. These recirculated particles collide again with the new incoming feed particles. The powder remains in the mill until its size is reduced sufficiently. Later it leaves via the sieves. The fluid energy mill produces particles with narrow size distribution. Next, in this figure, we will easily understand the working of fluid energy mill. From the solid inlet, we insert the powder or particles. After they get enter into elliptical pipe, below there are small openings for the which supplies high velocity airflow in the elliptical pipe. This high velocity airflow creates some pressure on particles, and the particles get collide with each other and they rub and the size is reduced. The zone of turbulence is shown where the particles collide with each other, and again also they collide with the surface of an elliptical pipe of fluid energy mill and their size is reduced. The small particles are removed by the outlet, and the bigger particles whose size is not yet reduced, they recirculate again and again up to their size is not reduced sufficiently. Next, pharmaceutical uses of fluid energy mill. Fluidized energy is used in milling thermolabile materials, example sulfonamides, vitamins, and antibiotics. Thermolabile substances means those substances which are is radially destroyed or deactivated by heat, like sulfonamides. The fluid for the size reduction, fluid energy mill is very useful. It is the choice of mill when higher degree of drug purity is required. Fluidized energy mill is used for the fine grinding of frets, kaolin, zircon, titanium, and calcium, alumina. Next, advantages of fluid energy mill. The machine has no moving parts and thus the tendency of contamination due to wear of parts is minimized. Means no wear and tear of the parts is there. The equipment is easily sterilized. Small particle size between 2 and 10 is usually obtained at the end of milling. Thermolabile materials can be milled with little degradation since the heat produced by the process is nullified by the cooling effect of the expansion of the compressed gas. Disadvantages: tendency of forming aggregates and agglomerates after the milling. Aggregates or agglomerates means small particles are get attached to the surface or stick to the or remain at the corner of the chamber or equipment. Next, generation of amorphous content due to high energy impact. Next, formation of ultrafine particles and not suitable for milling of soft tacky materials. Thank you. Please like, share and comment on video, and don't forget to subscribe the channel and hit the bell icon to get notification for new video. Thank you.